Okay, so andyan pa kayo?
Yes, sir.
Ayan. So balik tayo. So ni-record ko lang, kalimutan ko record para just in case sa mga kaklase nyo ano, hindi nakaten ngayon, at least may babalikan silang lecture. So, ayan. So balik tayo. Ang depth ng ocean natin is 8,000 feet. So, susolve natin yan. So, paano natin isolve yan? Alam natin, pressure is equivalent to the gamma gravity times the height. Or, pwede rin sabihin natin density times the height. Okay? So, meron tayong given na height. So, meron tayong, ang ating fluid dito is sabi, ocean. So, ibig sabihin, ang ocean ay, ano bang ocean? That is salt water. Alam natin ang specific gravity. So, ibibigay ko sa inyo specific gravity ng salt water. Ang specific gravity ng salt water is 1.03. So, solving, specific gravity sabi, is equals to density ng fluid all over density ng water. So, meron tayo specific gravity na 1.03 is equals to density ng fluid all over density ng water. Ano yung density ng water? 1,000 kilograms per cubic meter. Pero ito ay English units, that will be 62.4 pound per cubic foot. So, paki-compute nga ano yung density ng salt water natin. May calculator ba kayo? So, magsalita na lang ha yung nagko-compute, yung makakapag-compute. Pwede rin i-message na lang dito sa chat ha, yung sagot. So, para interactive tayo, para at least alam ko nakikinig pa kayo sa akin. Ayan. O, may nakasagot na? Si Maglangke. Albert, may sagot ka na? O, sige. So, sagot ay 64.272 pound per cubic foot. So, alam na natin yung density ng salt water. So, we can move to compute the pressure. Pressure is density ng salt water 64.272 pound per cubic foot multiplied by our height na 8,000 foot. So, makakancel si foot, magiging foot squared na lang to. Ano yung ating pressure? Yan. Yan. So, sana mag-compute din kayo para ano ha, para nasusundan nyo rin. So, pressure natin ay ilan? $514, sabi ni Altes, 514,176 pound force per
70.
foot squared. So, ito yung ating final answer. Okay? So, any question? Wala? Walang tanong? So, next problem tayo. So the pressure reading in PSIA in kilopascals is, so madali lang to, conversion lang to. So meron tayong given na pressure na 35 PSIA. Convert lang natin siya into kilopascals. So sabi nga 'di ba, ang ating 1 ATM is equivalent to 14.7 PSI, and kapag kPa siya, that is 101.325 kPa. So, convert lang natin si 35 PSIA, pounds per inch squared, times or multiplied by 14.7 pounds per inch squared all over 101.325. That is kPa. So, ano yung ating sagot na pressure? So, 35 times 14.7 over 101.325. So, sagot ay double check, Bikiso. Okay, sorry, mali pala ako. Wait lang ha. Paano magbura dito? Paano magbura sa eraser? So, mali pala ako, sorry. Correction, correction. May mali tayo. Baliktad yung ginawa ko. So, may mali ako, sorry. Baliktad, dapat ang nasa taas yung 101.325. Kasi hindi makakancel yun. Dapat nasa baba si 14.7 pounds per squared. Ayan. So, yan. Para makancel yan. Kasi pag nasa taas, hindi siya makakancel. Magmumultiply lang yung units natin. So, ilan tayo? 300. Double check nyo na lang at 340. 2.575 kPa. So, yun yung sagot natin for question number 2. Then, question number 3. Ito, madali lang. O, temperature. Convert 400 Kelvin into degree Rankine. So, paano yan? So, 400 Kelvin, convert muna natin into degree C. So, 400 minus 273. So, para maging degree C siya, so degree C, 400 minus 273, that will be 127 degrees C. So, pinakita ko sa inyo yung shortcut formula kanina ng computation ng conversion ng degree Celsius to degree Fahrenheit. Pero, pwede natin gamitin yung pinagmulan ng kanyang equation, yung interpolation. Interpolate lang natin yung freezing point tsaka boiling point ni degree C at tsaka ni degree Fahrenheit. So, sabi 'di ba, sa degree C, 100 degrees C ang boiling point natin, 0 degrees C ang freezing point. Sa Fahrenheit, we have 212, 212 degree Fahrenheit ang boiling point natin, then 32 degrees Fahrenheit ang ating freezing point temperature. Ang ating i-convert is 127 degrees C. Ang ating Fahrenheit ay yun yung ating hahanapin. So, interpolate lang natin. Alam ko marunong kayo mag-interpolate na. So, 100. So, that is upper value, 100 minus middle value, 127 minus 127 all over upper minus lower value is equals to upper 212 minus F all over 212 minus 32. So, shift solve natin. Ano yung magiging F natin? Yan. So, kung may sagot na kayo, no, pwedeng mag-microphone na lang kayo. Mas maganda yung makakapag-microphone, mag-microphone na lang. So, ano sagot natin? Fahrenheit ay 260.6.
3.6.
Oh, degree Fahrenheit. Ngayon, para ma-convert natin ito rangkain, add lang tayo ng 460. So, yung rangkain niya ay 260 plus 460. That is 720 degree rangkain. Ayan yung final answer natin. Okay? So, next problem tayo para mabilis. Problem 4. If the degree Fahrenheit scale is twice the degree centigrade scale, what will be the corresponding reading in each scale? So, paano yun? Medyo nakakalito. Sabi, if the degree Fahrenheit scale, sabi, kung ang degree Fahrenheit scale daw natin ay equivalent sa twice ng degree Celsius scale, ano yung magiging corresponding reading natin sa each scale? So, yung shortcut form, kung gagamitin natin yung shortcut formula, yung na-derive gamit sa interpolation, degree Fahrenheit is equivalent to 9/5 degrees Celsius plus 32. And the degree C, sorry, ayan. So, and sabi, degree Fahrenheit is equals to 2C. So, therefore, kung degree Fahrenheit is equals to 2C, substitute natin si 2C kay degree Fahrenheit. Magiging 2 degrees C. So, sinubstitute lang natin siya dito. Is equals to 9/5 C plus 32. Simplifying, makakakuha tayo ng degree C. Pag sinipsolve natin yan ng 160. So, kung alam natin C is 160, pwede na tayong mag-solve ng degree F is equals to, substitute naman natin tong equation na ito sa equation na ito. That will be 2 times 160. So, degree Fahrenheit will be equivalent to 2 times 160, that is 320. Ayan. So, that is the answer. So, may tanong. Okay, so next problem tayo. Water enters a condenser at 35 degrees C. So, meron tayong change in temperature dito. So, initial daw natin pumasok si water sa condenser na 35 degrees C. And leaves at 40 degrees C. Meron tayong T2 na 40 degrees C. What is the temperature difference in degree Fahrenheit? So, alam natin, di ba, delta T or change in temperature is T2 minus T1. So, solving for delta T, that is 35 minus, sorry, that is, mali pala. Sir, Tad. T2 is 40 minus 35. So 40 minus 35, that is, sorry, 25. Given natin, 25, 35. 35 pala given natin, that is only 5. Delta T is equals to 5 degrees C. So, solving for the conversion, our delta F all over delta C is equals to 9 over 5. So, kunin lang natin yung ratio. Ang delta F natin, ang ating hinahanap, all over, yung na-compute nating delta C, which is yun yung delta T natin, na 5 degrees C. Equals lang natin kay 9 over 5 yung ating ratio. Makakapag-compute na tayo ng ating delta F. So, ano yung ating delta F? Delta F, that is x over 5 is equals to 9 over 5. Ano sagot nyo? So, pwede itong cancel. Yan. So, delta F is 9 degree Fahrenheit. So, next question tayo. Okay. Question number 6. Sabi, a spherical tank is full of water that has a total mass of 10,000 kilograms. So we are have given a 10,000 kilograms. Then if the outside diameter, meron tayong given na outside diameter na 2,722 millimeters. How thick is the wall of the tank? So ang ating hinahanap is thickness nung tank. So i-visualize natin yung tank. So yung tank natin is supposedly spherical. So circle siya. Ito yung ating inner part ng tank. Ito yung thickness niya. So kung meron tayong gitna, this will be our inner radius. Kapag isinama natin yung thickness, ito yung ating thickness naman. So yan. That is the thickness. Yun yung ating hinahanap. Ngayon, kapag pinagsama natin yung dalawa, that is our outside diameter. Outside radius. So, outside radius, yan. So, mahirap magkamali dito. So radius. So, looking back, the formula for the density is mass over volume. So, yan yung ating equation for density. So, simplifying, kapag nilaro natin yan, yung volume natin will be mass over density. So, solving for the volume, so sabi ang mass natin is 10,000 kilograms all over our density. Sabi ang laman ng ating tank is water. So, ang density ng water ay 1,000 kilograms per cubic meter. So, 10,000 over 1,000 kilograms per cubic meter. Maka-cancel si kilogram. Our volume will be 10 cubic meter. So, divide lang natin ng 1,000. Ayan, magiging 10. Next, alam na natin yung volume natin. Pero pwede nating sabihin, since kailangan kasi natin yung thickness, kailangan natin yung volume ng tank using solid mensuration. So, ang volume ng tank natin, ibabase natin sa shape niya, that will be 4/3 pi r cube. So, kung naaalala nyo to sa solid mensuration, ha? Galing yan sa solid mensuration. Yan yung volume ng sphere. So, given tayo ng 2722 millimeters. So, para makuha natin yung outside radius, 2722 millimeters, divide lang natin sa 2. Excuse me, that will be 1,337 millimeters or 1.337 meters. So, solving for the inner volume. So, kunin muna natin yung inner volume ng ating sphere. So, yun yung volume. So, kung titingnan natin yung volume ng sphere na inner, using the inner diameter, ay same sa volume ng ating water. Since yung water is sumusunod lang naman sa shape ng ating sphere. Kaya pwede natin gamitin ito, si volume ng sphere, para makompute natin yung ating inner radius. So, given tayo, meron tayo na-compute kaninang volume ng water natin na 10 cubic meters, equals lang siya kay 4/3 pi times yung radius natin. So, ang ating radius na hinanap dito is inner radius cube. So, ship solve, no? Makakakuha tayo ng radius na ilan? Ayan. So, ang compute natin dito ay 1.3365 meters. Yun yung ating inner radius.
Yung outer diameter, sir.
Oo, mali pala, sorry. Oo, mali ang outer diameter.
1,361, sir.
Sagit lang ha. Nahilo ako dito sa pinrepair ko kagabi. Pointer options. Ano yung ano? Ano yung na-compute nyo?
1,361, sir.
136.
Millimeter or 1 point.
So, ayan, 1,361 millimeters or 1.361 meters. So, to find thickness, ang thickness natin is, kung titingnan natin dito sa drawing natin, sabi natin yung thickness natin is simply the outside radius minus the inside radius. So, thickness will be RO natin, which is 1.361 minus 1.3365. So, meters.
0.02 meters.
That is 0.024 meters. Or, that is 24 millimeters. Yan. So, may tanong. Ayan. Any question? So, kung wala nang tanong, move on tayo sa next problem. So, problem number 7. 100 kilograms of water are mixed with 150 grams of alcohol. That is, ang density daw ng alcohol natin is 790 kilograms per cubic meters. Ang hinahanap natin dito, specific volume ng resulting mixture. So, yung specific volume nitong, pag pinagsama natin si volume ni water plus volume ni alcohol, pag pinagsama natin, ano yung kanyang specific volume. Okay, so meron tayong given na mass na 100 grams. So, mass ng H2O or water. Then, meron din tayong given na mass ni alcohol, that is 150 grams. Ang density ng alcohol given na 790 kilograms per cubic meter. So, convert natin si 150 grams, that will be 0.15 kilograms. Ito ay 0.1 kilograms. So, using the mass balance, ang ating mass total should be mass ng water plus mass ng alcohol. So, mass total will be mass natin na 0.1 kilograms plus 0.15 kilograms, that is 0.25 kilograms. Yun yung ating mass total. So, alam natin, ang density is mass over volume. So, meron tayong, kailangan natin mahanap is yung volume ng ating water, tsaka volume ng alcohol. So, density ng alcohol is equals to mass over volume ng alcohol. So, unahin natin sa water. Density ng water, given na yan, 1,000 kilograms per cubic meters is equals to mass natin na 0.1 kilograms over volume. So, ano yung volume natin ni water? Solving 1,000 divided by 0.1, that is paki-compute. Volume ng water ilan? Habang sino-compute, ipapakita ko naman yung sa alcohol naman. Ang mass ng alcohol is 0.15 kilograms. All over volume ng alcohol is equals to, given yung ating density na 790 kilograms per cubic meters. So, may na-compute na volume ng alcohol. Volume ng water, sorry. Hindi. 1,000, kukross multiply mo to. So, magiging 1,000 divided by 0.1 lang. Sorry. 1,000. Teka, parang ganun. Get 1,000 Sorry, baliktad pala. Ang gagawin mo dyan is 0.1 divided by 1,000 pala. 0.1 divide nyo ng 1,000. So, baliktad pala ako. Sorry. Yung iba, si Altes lang ata nakikita ko nagko-compute.
24 lang.
Ayan. So, that is 1 times 10 raised to negative 4. That is cubic meters. So, yung volume naman ng alcohol, bigay ko na nga lang para mabilis tayo. Volume ng alcohol is 0.15. Divide lang natin kay 790. That is 1.8987 approximately times 10 raised to negative 4 times 10 raised to negative 4. Ayan. So, solving for the volume ng mixture, that will be 1 times 10 raised to negative 4 plus 1.8987 times 10 raised to negative 4. So, that will be approximately, volume ng ating mixture ay 1.159494 times 10 raised to negative 3 cubic meters per kilogram. So, sige, tuloy-tuloy na natin. Number 8. Given steam pressure of 900 pound per foot squared. Temperature of, so meron tayong pressure na 900 PSF. And temperature na 300 degrees Fahrenheit. Ang specific volume natin is 5.8. Cubic foot per pound. Then we have the specific enthalpy na 9,500 foot pound force per pound mass. What is the internal energy per pound of the system? So, before we start solving that, so ituloy pala muna natin yung lecture. Wait tayo kasi hindi natin na-review yan. Okay, so punta tayo kay heat and entropy. Kapag sinabing heat is a form of energy associated with the kinetic random motion of a large number of molecules. So, ang heat natin, marami kasi tayong klase ng heat, no? Meron tayong dalawang main type. We have the sensible heat and latent heat. Kapag sensible heat, ang keyword lang dyan, heat that is needed to change the temperature of the body without changing its phase. So, ibig sabihin, nagbabago yung temperature natin, pero hindi nagbabago yung phase ng ating liquid. So, halimbawa dyan, kapag nagpapakulo tayo ng tubig, nagiging saturated, water yung ating tubig from subcooled liquid. So, nagbabago yung temperature natin, pero liquid pa rin yung tubig natin. That is sensible heat. So, ang sensible heat natin is simply MC delta T. Yung M natin is mass, C is specific heat, and delta T is the change in temperature. Then we have the latent heat. Ang latent heat naman is kabaliktaran naman. Yun yung heat na needed ng body para mag-change phase siya without changing its temperature. So, nagbabago yung phase niya, pero hindi nagbabago yung temperature. So, example ulit sa tubig ulit, yung steam natin, kapag na-reach niya yung yung saturated temperature, mukulo na siya. At that time, hindi nagbabago yung temperature natin, 100 degrees Celsius pa rin siya. Pero, pag nagpapakulo tayo ng tubig, nauubos yung tubig natin, nag-evaporate siya. So, nag-change yung phase natin doon, nagiging gas, si liquid, pero yung temperature natin is still at 100 degrees centigrade. So, simply, ang latent heat natin is simply equals to the mass times the latent heat of fusion or vaporization. So, ito given dito sa baba yung standard values for ice at saka boiling water. So, next slide tayo. Then we have the entropy. Entropy is simply the measure of randomness ng molecules or substance natin. So, kapag mas magulo, mas mataas ang entropy. Mas maayos, mababa ang entropy natin. Yun lang yun, no? So, sa kwarto nyo, pag makalat yung kwarto nyo, ibig sabihin, mataas yung entropy natin. Pero kung malinis ang kwarto nyo, mababa ang entropy natin. Yun yung pinaka layman's term na explanation ni entropy. Then we have the enthalpy and internal energy. Enthalpy, heat energy that transferred to a substance at a constant pressure process. And the internal energy is simply yun yung energy stored within the body of system natin. So, sum siya ng kinetic energy plus other constituting energy such as potential energy and others. So, ang ating enthalpy is the combination from the non-flow energy equation, that is internal energy plus the work or the pressure times the volume. So, tuloy-tuloy ko na isama. First law of thermodynamics natin. First law of thermodynamics simply state the energy conservation law. So sabi dito, energy cannot be created nor destroyed. It can only be transformed. So ibig sabihin dyan, kung may ipinasok ka sa system, meron tayong katumbas na ilalabas sa system. So hindi po pwedeng pasok ka lang ng pasok, wala kang lalabas. So dapat, lahat ng ipinasok natin, may katumbas siya na ilalabas ka dyan. Okay? So, yun yung principle ni first law of thermodynamics. So, in an open system, this is the formula for the first law of thermodynamics or energy balance. Simply say that energy in is equals to energy out. So, pinasok mo, nilabas mo. Then we have the second law, which is known as the law of increased entropy. Then it is profound principle of nature which affects the way energy can be used while quantity remains the same in the first law. Then the quality of material energy deteriorates gradually over time. The second law of thermodynamics is general principle which places constraints upon the direction of heat and the attainable efficiencies of heat engine. Ibig sabihin, sa second law, dinidescribe lang niya sa atin yung movement ng heat and yung limitations ng ating heat engine. So, meron itong dalawang main statement na gamit. The Clausius statement and the Kelvin-Planck statement. So, the Clausius statement states that it is impossible to construct a heat pump that operates without an input work. Ibig sabihin, hindi po pwedeng magkaroon tayo ng pump na wala tayong input work. Dapat meron tayong input work. Okay? Wala tayong self-acting heat pump. Then, kay Kelvin-Planck statement, it is impossible to construct a heat engine which operates in a cycle and receives a given amount of heat from high temperature body and thus an equal amount of heat. Ibig sabihin, hindi po pwedeng mas mataas yung efficiency ng heat engine mo sa 100%. Yun lang yun. Ibig sabihin, yung napapump ng heat natin, ng heat engine natin na heat, hindi po pwedeng mas mataas sa input work natin. Then, the third law of thermodynamics, sabi, the total entropy of a pure substance approaches zero as the absolute thermodynamics approaches to zero. So, it simply describes the temperature relationship. to entropy. And the zeroth law of thermodynamics is simply, sinasabi lang niya na kapag ang heat transfer natin, kapag equilibrium sa third body, equal silang tatlo. So example nun is yung kapag gumagamit tayo ng thermometer, kapag iniipit natin yung thermometer natin sa kilikili natin, so yun yung third body natin, yung thermometer. Ibig sabihin, kung ano yung temperature ng katawan natin, yun na rin yung nagiging temperature ng thermometer. So yun lang yung binabanggit kay zeroth law of thermodynamics. So ituloy na natin. Number na ba tayo? So, anong number na nga ba tayo? Ayan. Anong number na tayo? Pakibalikan nga. Kalimutan ko.
7 yata, sir.
7. 7. Hindi ko save. Ah, 8.
8.
Ayan, 8. So, given a steam pressure of 900 pounds per foot squared, temperature at 300 degrees Fahrenheit, specific volume of 5.8 foot per pound. The specific enthalpy is 9,500 foot per pound mass. What is the internal energy per pound of the system? So, ang hinanap lang natin is internal energy. So, U. So, U is equals to, so, yun yung ating hinahanap. So, sabi, enthalpy is equals to U plus PV. So, kung enthalpy is U plus PV, so U will be equivalent to H minus PV. So, solving for U, we have H. Meron tayong given H na 9,500 foot pound force per pound mass minus yung ating P na 9,900 pound per feet squared times volume natin na 5.8 cubic foot per pound mass. So, solving, makakancel si cube, si feet squared makakancel, matitira na lang, pound to a pound force, foot per pound mass. So, ang U natin will be 9,500 minus ito, ilan? That is
4,280.
4,280 foot pound force per pound mass. So, next problem. Ayan, number 9. Nalaglag na ang calculator. Heat, air, and fuel. Enter a furnace. Used for home heating. And the air has an enthalpy of 302 kilojoules per kilogram. And the fuel has an enthalpy of 43,207 kilojoules per kilogram. The gases leaving the furnace have an enthalpy of 616 kilojoules per kilogram. There are 17 kilograms of air per kilogram of fuel. The house requires 17.6 kilowatts of heat. What is the fuel consumption per day? So, itong problem na to, mukha lang siyang komplikado na combustion problem, but this problem or problem about furnace, pero ito ay solvable lang ito using the first law of thermodynamics, which is yung ating energy balance. So, halimbawa ito yung ating furnace. Sinasabi lang dito, may input tayo na air, and fuel. Okay? May input tayong air at saka fuel. So, then, may ultimate output tayo na yung heat natin, which is yung ating ginagamit sa heating, na yung ating heating 17.6 kilowatts of heat. So, 17.6 kilowatts. Ang ating hinahanap daw is ilan yung ating mass ng fuel. Sorry. Meron din tayo palang output na ulitin natin. So, ang air at fuel natin pumapasok sa system natin para magka-output tayo ng heat na ginagamit natin sa bahay. And, syempre, kailangan din natin may output din tayo ng yung ating exhaust gas na given tayo ng enthalpy ng air na 302 kilojoules per kilogram. So, gas is leaving the furnace. Yung ating exhaust gas, ang enthalpy naman ng exhaust gas natin ay 616 kilojoules per kilogram. Ito ay enthalpy ng air. Then, we have the 17 kilograms of air per kilogram of fuel. So the house requires 17.6 kilowatts of heat. Then, ang ating hinahanap is fuel consumption per day. So, mass ng fuel per day ang ating hinahanap. So, double check ang ating fuel. Ayan. Ang given lang pala sa atin dito sa fuel is the air-fuel ratio. Ang ating given is ito. Ito yung ating given. May given sa ating air-fuel ratio. So, RAF natin, that is 17 kilogram air per kilogram fuel. Ayan. So, yan yung ating given. So, kung titingnan natin, sa equation na yan, makakapag-mass balance tayo dyan. So, energy in is equals to energy out. So, unahin muna natin yung mass muna natin. So, mag-mass balance muna tayo. So, kung mass balance muna ang ating gagamitin, so, compute natin, lahat ng pumasok ay equal sa lahat ng lumabas. So, meron tayong mass ng air plus mass ng fuel is equals to mass ng exhaust gas. Okay, take note natin. Ang ating air-fuel ratio is equals to kilogram air per kilogram fuel. So, that is mass ng air all over mass ng fuel. So, given tayo ng exhaust gas na air-fuel ratio 17, kilogram air per kilogram gas, that is equals to MA plus over MF. So, therefore, pag sinimplify natin MA, that will be 17 MF. So, substituting the value, so let this be equation 1. So, and this will be, so ito na lang, equation 2 na lang para to, equation 2, this will be equation 1. So, equation 1, equation 2. Substituting equation 1 to 2, or equation 2 to equation 1, ang MA natin is magiging 17 MF plus MF is equals to mg. So, therefore, ang ating mg will be 18 mass ng fuel. So, gamitin na natin yung heat balance. Ngayon, heat balance naman ang ating gagawin. Heat balance natin is lahat na ay involved. Kasama na dito yung enthalpy natin tsaka Q. So, meron tayong input na mass ng air at tsaka enthalpy ng air plus mass ng fuel times enthalpy ng fuel. Ang nilabas natin is mass ng gas or exhaust gas times the enthalpy ng exhaust gas plus yung ating heat energy. Okay. So, ang ating hinahanap dito is mass ng fuel. So, simplifying, mass ng fuel, H ng fuel is equals to mass ng gas, enthalpy ng gas, plus Q minus mass ng air, enthalpy ng air. So, divide natin both sides by enthalpy ng fuel. So, makititira, meron na tayong working equation for the mass ng fuel which is mg hg plus q minus ma ha, mg. Yan, hilo na. So, ayan. So, ma, that is ma minus ma ha all over hf. Yan, wala. So, mass ng fuel, plugin natin yung values. So, mg natin, that is 18 mf. Enthalpy ng gas, that is 616 kilojoules per kilogram. Minus, plus, heat energy natin, that is 17.6 kilojoules per second. Kilowatts is equivalent to kilojoules per second. Pakitandaan na lang. Minus, MAHA, that is 17 mf times yung ating HA ay 302 kilojoules per kilogram. Then divided both sides by enthalpy ng fuel natin na 43,207 kilojoules per kilogram. So, canceling yung mga makakancel. So, matitira dito mass ng fuel. So, mas kakancel din to. Matitira na lang is mass ng fuel. Ano yung mass ng fuel natin? That is 4.27, 4.72, 72, ayan, 4.72, 44, 517 times 10 raised to negative 4. That is kilograms per second. Since ang hinahanap natin is per day, convert lang natin sa second ng day. We have 3,600 seconds per hour and 24 hours per day. So, mga cancel si R, seconds, mga cancel din. Ang mass ng fuel natin per day should be 40.819 kilograms per day. So, ito yung ating final answer. Any question? Yan, medyo mahaba lang yung solution niya. So, may tanong? Andiyan pa kayo, no? Ito pa ba kayo? Ayan, nandiyan pa kayo. So may tanong. Okay, kung wala, proceed tayo next problem. Number 10. So number 10, proceed tayo. So new topic to. Uh, that is the ideal gas or perfect gas naman tayo ngayon. So ideal gas law, simply defined is, it is as the one in which all collisions between atoms or molecules are perfectly elastic and there are no intermolecular or attractive forces. So, pinaka-pina-follow nito, Boyle's law and Charles' law. And the subscript Charles' law, which is Guy-Lussac's law. So, ideal gases are gases whose compressibility factor is equal or very near to 1.0. So, meron tayong tatlong equation for gas law. One is PVMRT. So, alam ko, familiar sa inyo to, paborito mo. So, kapag given yung mass, paborito mo. Okay? Or PVNRT kapag moles, then ito, yung hindi masyadong common sa atin kapag Boltzmann constant ang gamit. Ayan. So, value ng universal gas constant, that is 8.3143 joules per mole Kelvin or kilojoules per mole Kelvin. So, ang code dito, para mas madaling maalala, it's true, 8 for it's, 3 for true, 1 for 3, 1 for 3 is I love you. So, it's true, I love you. Para mas madali nyo maalala. Then, 1545 foot-pound force per mole Rankine or 0.0821 liters atmosphere per mole Kelvin. So, finding the value of a gas constant, given the universal gas constant, basahin nyo na lang to, madali lang to. So, di-divide nyo lang yung universal gas constant to the molecular weight nung gas ninyo. Gas constant of air, standard. Ito yung value, 53.34 or 0.287 kilojoules per kilogram Kelvin. Then, this is the relationship ng Cp, Cv, K, and R. Ayan. Then, ito na yon. Yung ating general gas law versus the Boyle's law. Kapag ang temperature natin is constant, yung volume natin is inversely proportional to the absolute pressure. So, that is P1 V1 is equals to P2 V2. Kapag kay Charles naman, kapag yung ating pressure naman ang constant, si volume naman ay directly proportional to absolute temperature. So, V1 over T1 is equals to V2 all over T2. Then, ito yung variation ni Charles law, which is Guy-Lussac law. So, kapag ang volume naman ang constant natin, ang absolute pressure naman ang directly proportional kay temperature. That is, P1 over T1 is equals to P2 all over T2. Then, combined gas law, pag pinagsama natin, we have P1 V1 all over T1 is equals to P2 V2 all over T2. Take note, sa lahat ng law na yon, pressure and temperature must be in absolute scale. Then, we have the Dalton's law of partial pressure. So, kapag may partial pressure tayo, pag-add lang natin lahat ng pressure, that is our total pressure. Then, Avogadro's law, ang ratio ng mass natin ay equal lang sa ratio ng molecular weight. Same goes with the gas constant natin. Ang ratio ng gas constant ay equal sa ratio ng molecular weight. Then, this is the equation for internal energy, enthalpy, and entropy for ideal gases. So, yung tatlong to. So, mcv delta T, mcp delta T, at saka mc lone T2 over T1. Yan. So, sige. Next example tayo. An automobile tire is inflated to 30 psig. So, given tayo ng P1, which is pinalobo natin, hinanginan natin yung gulong into 30 psig. Na ang temperature 1 natin, ang temperature natin is 50 degree Fahrenheit. So, nagmaneho tayo, pinatakbo natin yung kotse, tumaas yung temperature ng gulong natin since umiikot yan dahil sa due to friction into T2 na 75 degrees Fahrenheit. So, ang ating kailangan is, ano yung ating final gauge pressure? Assuming that the volume remains constant. So, sa gulong, hindi naman nagbabago ang volume ng gulong natin. kung ano yung volume natin, yun pa rin. So, madali lang yan using the general gas law. Constant volume tayo, so that will be P1 over P2 is equals to T1 all over P2. So, P1 natin is, so dito ko na nilagay, 30 PSIG plus 14.7 PSI, yun yung ating atmospheric pressure, all over yung ating hinahanap na P2 plus 14.7 PSI is equals to T1 natin na 50 degree Fahrenheit plus 460 para maging Rankine, all over T2 na 75 degree Fahrenheit plus 460. So solving, ano yung makukuha nating P2 na gauge pressure?
$32.19, sir.
Ayan. So 32.19
$32.9.
PSIG. So yan yung magiging final pressure ng ating gulong. So basic lang yung solving ng general gas law. So another example. Example number 11. So ito may kasamang heat energy. A group of 50 persons attend a secret meeting in a room which is 12 meters wide, 10 meters long, and the ceiling height of 3 meters. So meron tayong room na ang volume natin is 12 by 10 by 3 meters. So paki-compute na lang yung volume na to. And the room is completely sealed off and insulated. Each person, so ang nagbibigay ng heat na 150 kilocalories per hour per person of heat and occupies a volume of, so ang volume ng per person, so volume ng person ay 0.2 cubic meters. The room has an initial pressure, so meron tayong P1 na 101.3 kPa and initial temperature na 16 degrees C. Calculate the room temperature after 10 minutes. So, ano yung ating temperature after 10 minutes dyan? So, ano yung na-compute yung volume natin ng room? 12 times 10 times 3.
360, sir.
Ilan? 360 cubic meters. Okay, alam na natin. So, ang ating hinahanap is 10 after T after 10 minutes. So first, kailangan nating hanapin muna is yung volume ng air. Volume ng air is simply the volume ng room, yun yung ating volume na kinumpute kanina, plus volume ng person na total. Okay? So, kung kukumpitin natin yan, that will be volume ng room 360 cubic meters plus volume ng person sa total. Sabi, kada person ay 0.2 cubic meters. Multiply natin ng 50. Since 50 persons yung attendance. So, ano yung ating volume ng air? So, hindi yan sorry, hindi pala plus yan. That should be minus. Ayan. So, minus, yan. So, 360 minus 0.2 times 50. Ilan yung air natin? That is 360.2 times 50. That is 10. That is 350 cubic meters na volume ng air natin. Okay, so may volume na tayo ng air. Pwede na tayong mag-general gas law. Mass ng air, galing sa PVMRT, that is PV all over RT. So solving, we have the pressure na 101.3 kPa multiplied by the volume na 350 all over R, which is 0.287 times the temperature natin, T1, which is 16 plus 273. So, makakompute na natin yung mass. Mass will be equals to 427. So, ito yung total mass ng air natin. 0.46 kilograms. So, given tayo, alam natin 150 kilocalories ang Q ng air natin. So, Q, air total, is 150 kilocalories. So, 150 kilocalories per hour per person times, sabi, 50 persons. So, maka-cancel si persons. Q80 will be now 7,500 kilocalories per hour. So, Q is equals to, since ang ating problem ay constant volume process, take note, constant volume to kasi ang volume ng room ay hindi naman nagbabago. Ang ating gagamitin dito ay specific heat, constant volume. Since constant volume process tayo, kaya maging M, CV, delta T. So, meron tayong M, may CV tayo, may T1 na tayo, makukuha na natin yung T2. Okay? So, Q natin, which is 7,500 kilocalories per hour, times, sabi, ang ating hinahanap is at after 10 minutes ng staying sa room. So, i-convert natin 10 minutes into hour. So, 10 minutes, that is 60 minutes per hour. So, maka-cancel si R, equals to mass natin na 427.46 kilograms times CV ng air is, that is 0.171. So, constant to, kilocalories per kilogram Kelvin. Multiplied by the change in temperature, yung ating hinahanap na T2 minus 16. So, hindi na kailangan i-convert pa ng Kelvin si 16 since equal lang naman yung change in temperature sa Kelvin. So, maka-cancel si Kelvin. Kilocalories, maka-cancel. Kilograms, maka-cancel. Matitira, temperature na lang. So, ito, cancel din. Ano yung ating T2? That is
33.1.
33.1 degrees centigrade. So, number 12. If the initial volume of an ideal gas is compressed to 1/2. So, sabi, ang ating V1 daw ay kinompress sa 1/2. So, ating magiging V2 of each original volume. So, magiging 1/2 V1. And to twice its original temperature. So, P1 is P2 and yung ating original temperature daw ay madodoble. Ang ating pressure daw ay anong mangyayari? So, P2 should be equals to ano? So, using the combined gas law here, P1 V1 all over T1 is equals to P2 V2 all over T2. So, solve natin. Substitute natin yung values dito. We have P1 V1 all over T1 is equals to P2 times yung V2 natin daw ay 1/2 V1. So, that is 0.5 V1. All over T1 naman, all over T2, Ang T2 naman natin is magiging, T1. So, ang T2 naman natin is magiging 2 T1. So, solving by multiplying or by dividing both sides. So, divide natin both sides ng 0.5 V1. So, 0.5 V1. So, makakancel. So, makakancel si V1 natin. Ang matitira dito, so, meron tayong matitirang T1 pa. So, pwede rin natin i-multiply naman ng T1 both sides. So, T1. So, ito makakancel si T1 dito both sides. Matitira dito, sa kabila is P1 all over 0.5 is equals to P2 all over 2. So, simplifying, makukuha natin dyan, P2 is equals to 4 P1. Ayan. So, sige, tapusin na natin. Last 3 problems na tayo. So, tapos na tayo. So, thermodynamic processes tayo. So, whenever a system goes any change, it is said to have a described process. So, meron tayong dalawang klaseng work sa process. We have the non-flow work or the non-flow process and steady flow process. Non-flow process, kapag sa closed system, steady flow kapag open system. Halimbawa ng non-flow process, compressor. Mga compressor natin. Kapag sa steady flow naman, example is electric fan, turbine. Okay? Ang pinagkaiba nila, ang general equation ng work non-flow is P times delta V or PdV. While the work steady flow, baliktad naman. V, dP naman. Okay? Then, may dalawa tayong klase ng process. We have the reversible and irreversible process. Kapag reversible process, bumabalik sa original form yung ating process. Kapag irreversible process naman, hindi na siya nakakabalik sa original form niya. So, sa reversible process, example dun is yung mga ideal processes natin. Sa irreversible process, andun yung actual process natin. Okay? Then we have the cyclic process. Kapag nagbibigay siya ng same state or condition after the system undergoes a series of process. Then quasi-static process, kapag sobrang bagal yung process naman natin, na nagiging status quo siya or equilibrium siya internally. So, ito yung ating different processes of ideal gas. We have the isometric process. So, constant volume process. So, ito yon. Ito yung formula sa kanya. Isobaric process. Constant pressure process. So, reversible siya. Then, we have isothermal. Constant temperature. Reversible din siya. Isentropic. Constant entropy. So, dalawang klase ang isentropic process. May reversible tayo at irreversible. Pero for this sake, pag-uusapan lang natin is reversible. So, isentropic is also known as the adiabatic process. Ibig sabihin, wala tayong heat transfer sa system. Ayan. Then, we have the polytropic process. Yun naman yung special case, no? Yung PV raised to N. So, ito yung ating equations. General equation for thermodynamic curves. So, to summarize it lang, ang general equation natin, PV raised to N is equals to C. So, if N is equals to 0, isobaric process, N is equals to 1, isothermal, N is equals to K, isentropic process, then, kapag negative infinity, yung N natin, or positive infinity, polytropic process. Kapag hindi siya 0, hindi siya equal kay 0. Then kapag n is equals to infinity, isometric process. Take note lang, ang PVK is steeper sa PV curve. Hindi sila pareho. So, punta tayo sa sample problems para matapos na tayo. So, number 13. While the pressure remains constant at 689.5 kPa, so we have constant pressure tayo dito. So, may P tayo. Constant pressure process na 689.5 kPa. The volume of a system of air changes from, so meron tayong given na V1 is 0.567 cubic meters to V2 na 0.283 cubic meters. Ang hinahanap natin is change in internal energy or delta U. So what is the delta U? So delta U, general equation ng delta U is mCV delta T. So meron tayong given na change of volume lang dito. Okay? Wala tayong given na change in temperature. So, paano natin solve yan? So, to solve that, hanapin lang natin yung values ng T natin. Okay, so shortcutting ko na to para mabilis tayo. Delta U is equals to M CV. Yung delta T natin, that is T2 minus T1. Okay? So, ang T2 natin, pwede natin masolve yung T2 using PVMRT. That is P2 V2 all over MR minus P1 V1 all over MR. So, substituting the values, we have M na makakancel, sorry. Yan, M na makakancel. So, since pareho siya ng denominator, pwede nating ilabas na CR. So, magiging, ang mass natin is, makakancel. Ang CV na lang pala matitira sa atin. We have CV na 0.716 kilojoules per kilogram Kelvin. All over, yung R natin na 0.287 kilojoules per kilogram Kelvin. Times P2 natin, that is 689.5 multiplied by the V2, which is 283, 0.283, minus P1, that is 689.5 So, 689.5 times V1 na 0.567. So, solving, ano yung makukuha nating delta U dyan? So, this is kPa, cubic meters, kPa, cubic meters. So, delta U, ang delta U natin na masosolve ay 488.52 kilojoules. So, yan. So, number 14. What horsepower is required to isothermally compress 800 cubic foot of air? So, may volume tayo na 800 cubic foot of air per minute from P1 na 14.7 PSI to P2 na 120 PSI. So, tayo ay isothermal process. So, horsepower to isothermally compress. So, compressor siya. So, kapag compress, that is automatically a non-flow system. So, ang ating hinanap dyan is work non-flow. Ang work non-flow natin in an isothermal process is P1, V1, ln P2 all over, ln P1 all over P2. So, P1 all over P2. So, direct sub lang natin yan. P1 is 14.7 times V1, which is 800 cubic foot. So, teka. Para hindi tayo malito. Isama ko na yung conversion. This is 14.7 PSI. So, since foot yung ating volume, kailangan natin i-multiply si PSI ng 12 squared inch squared para makancel si inches squared maging feet squared na siya. So, that is 1 foot squared times the volume na 800 cubic foot times the ln P1 is 14.7 PSI all over 120 PSI. So, makakancel dito si PSI, inches, feet squared, feet cube, makakancel si cube, matitira isang feet. So, ating work non-flow will be pound foot. So, pound force foot per so, 40%. Okay, wala naman siyang wala siyang binigay na time. Okay. So, pound per force per foot. So, ang magiging sagot natin dyan is negative 3, 5, 5, 5, 6, 21.557 foot pound force. So, ito ay per minute pala to. Ayan. So, matitira ang per minute natin. So, since horsepower ang ating hinahanap, to convert that, divide lang natin si work non-flow na foot pound force into 33,000. Okay? Para maging horsepower. So, ang ating work now will be 107.7 107.7
75.
46 or 75 horsepower. Yan. Ayan. So, okay pa ba kayo dyan? Last problem na. O ito, last problem na natin to. How much work is necessary to compress air in an insulated cylinder from point 2 to point 1 cubic meters? Use T is equals to 20 degrees centigrade and P1 is 100 kPa. So, meron tayong V1 na 0.20 cubic meters to V2 na 0.01 cubic meters. So, sabi dito, how much work is this to an insulated cylinder? So, insulated, ibig sabihin, kapag insulated, system natin, ang heat ay hindi nakakalabas. So, adiabatic siya. So, therefore, that is an isentropic process. So, kung isentropic process siya, gamitin natin yung relationship for isentropic process. That is P1 V1 raised to K is equals to P2 V2 raised to K. So, simplify natin. So, P2 V1 raised to K. So, cancel. So, magiging P1 all over P2 is equals to V2 all over V1 raised to K. So, substitute natin yung values. We have P1 na 100 kPa over P2 is equals to V2 0.01 cubic meters all over 0.20 cubic meters. Raised to K, ang K is 1.4. So, ano yung P2 natin? That is 6,628.91 kPa. So, yan. Sagot natin. Pero, hindi pa yan tapos. Kasi ang ating hinahanap is work. So, work natin, in a non-flow system, kapag isentropic process, that is P2 V2 minus P1 V1 all over 1 minus K. Sorry, K minus 1 pala. Baliktad na naman. So, that is, hindi 1 minus K yan, K minus 1. So, K minus 1. So, solving P1, P2 6628.91 times V2, na 0.20, 0.20 minus P1, that is 100 kPa times 0.01 all over 1.4 minus 1. Ang sagot natin dito na work non-flow ay 115.7 kilojoules. So, any question?